So what I'm trying to show you today is how to derive molecular mass from our relationships of our gas laws. Now, all the individual variables, moles, pressure, temperature, volume, affect the pressure of a gas and the properties of a gas. So let's start with this formula called the ideal gas law, PV equals nRT. And this formula, of course, has been derived from the individual relationships of these components. And we're going to essentially derive from this relationship molecular mass. Molecular mass, as you probably recall, is nothing more than the grams per mole of a substance. Okay, so let's look at this formula here. Molecular mass is equal to the grams per mole. Now we've been using N here for moles, so we'll keep that same designation. And now what I'm going to do here is I'm going to try to find an equivalent for mole in terms of molecular mass. The link, of course, is molecular mass and mole have a relationship through grams. So given this relationship for molecular mass, I'm going to solve for N. And when I do so algebraically, N is going to equal to grams over molecular mass. And that, my friends, is the equivalent that I'm going to plug in for the N in my ideal gas law formula. So PV is equal to N, but N is equal to grams over molecular mass. So I'm going to put grams over that fancy M for molecular mass, and I've got my RT remaining. And all I have to do, party people, is now convert to molecular mass using algebra and simplification rules that you should know. I know that my molecular mass is going to go on top here, and it's going to equal, all right, let's make, let's see, grams. I have this grams here that's still on top. I'm going to bring the PV down to the bottom. Again, just algebra here. I'm not really breaking any new ground. Okay, I'm just simplifying. And then, of course, RT is still here. And there it is. Molecular mass is grams times the R, the universal gas constant, times the temperature in Kelvin, and then the pressure times the volume. Now, the R constant, of course, is very important to remember, okay, is the proportionality constant that we use for these relationships, but that its unit drives with the units of the others. Now, I can clean this up. I know that grams over volume is density, so I can write this another way. Molecular mass, okay, grams over volume is density D times the R T over the P. So I learned, a nice little funny way, is that molecular mass is dirt over P, which sounds to be some kind of etiquette that you may have when you're out in the wild. But in any case, that is my derivation. Now, if I want to continue this, which is pretty cool, you can get the molecular mass from the gas laws. And again, the key here is through the idea that molecular mass is grams per mole. Now, one little other derivation is to solve for density. So just rearranging density, right, bring the R and T down, so keeping my color coordination as I have. So R and T go down to the bottom. And of course, the pressure goes to the top. Again, another algebraic simplification. And what we get is PM over RT equals density, which I think to be a pretty cool derivation because that is a way to measure the density of a gas without have to put the gas on a scale, right? Pressure times its molecular mass. So knowing what kind of gas you have, its molecular mass, and the pressure and its temperature, you can get its density. Pretty cool. So these are the two derivations that continue through PV equals nRT that you're responsible for. Hope that helped.